We have the player ship in the game world, and now we'll bring in computer-controlled ships. We'll have to modify the mission file format in order to read it as text. Then we'll start the AI controller with a passive path-following behavior. Our new headquarters object will load the player, the NPC ships, and their paths. If we have time, we'll add ship damage from weapons. We'll be working with these two objects this time. We'll make a couple of changes to the ships to incorporate our changes. Our main focus will be implementing the passive AI to include these two AI modes. Finally, we'll make the headquarters object, which will load all the ships. But our first job is to convert the mission files like we did here with the map files. This one will take more work because we have to do more than just shift out of the lower 32 byte values. I'll show you what I mean. Let's hide the zeros for a moment. So with the map files, we just had to shift everything out of the lower 32 bytes because the data didn't go beyond this point. Well, now we have data that bleeds over into another control character space. So the plan is still to shift everything out of the C0 space. In C, we'll cast everything to 16 bits to give us more space on the right side, but for all the data in C1 and above, we'll shift them back and count the number of shifts it takes. It shouldn't take more than 1 or 2. By saving the shift count with the final byte value, we can rebuild this data file using only text reads. We'll just have to undo all the work we do in C inside of GameMaker after we read in the byte value. Let's go into Powershell and make sure we have all our files ready to go. Looks like all the files are still here from our asset video. Let's bring in a makefile and we'll make our own conversion utility in C. So our steps this time will be to change the output file name, open the files, go through each byte, we'll shift everything up 32 to make sure C0 is empty, then we'll shift everything at C1 or above until it's in a valid value. The new byte should be valid, then we'll write only the mission data we're interested in, which are the 20 ship types, the X values, and the Y values. Remember, each ship has 500 bytes for each path coordinate. So for the file name, this time I'm just going to punch out the extension by changing the first 2 letters. For example, I'm going to change TD2 to MS2. I need to keep the number so I can distinguish the episodes since they all share the same mission names. Also, there's a problem because episode 1 doesn't have a number. I'll just rename all those from TD to TD1 after we get this built. Open files. We'll go through each of the bytes in the files. Let's see, there's 20,080, which is 4E70 in hex. So we'll start our shift number at hex 20 since that's the lowest acceptable non-control character. This means 0 shift for our purposes. Read in the byte. We'll shift the byte up 20, guaranteeing that it's not in C0. So while it's higher than our upper threshold, we'll shift it down and count the number of times we shift. The new byte should always be a valid 8-bit UTF value. Now we're going to write the parts of the file that we're interested in. We discussed those sections back in our asset video, so I'm just going to throw in those byte positions here. Just to keep these sections short, I'm going to make a function that takes in the 2 values and a file pointer. Let's make that function. We'll write both the shift value and the byte value. I'll make sure there's a line dedicated for each byte. Now this is obviously not very efficient. Each original byte has become 4 bytes in our new file. Okay, so now we have to rename the first episode extensions from TD to TD1. Now let's test our code to make sure this works. Okay, there's a problem. I was expecting exactly a 4-to-1 growth, but it looks like we're short. Okay, we're missing the equality checks here. Let's fix that. Okay, let's hope that works. We won't know until we get into GameMaker and write the AI code to test. So let's bring the files in. Actually, I'll just bring in the first 5 files for now. Let's move on to the ship AI object. We're only going to build the parts that support the passive AI, which includes 2 of the 5 modes. Let's make the object. Then we'll create the enums for the modes. Again, we're only going to go for the move and finished mode at this time. Now we'll create the variables we'll be using this time. The current mode will start in passive move mode. This is the flag that says if the AI completed its mission, which is always completing the path. Finally, the index of the current position on the path. This will fall between 0 and 500. Agent is the handle to the ship that the AI controls. Remember, each ship object will have a dedicated AI object. Each AI will know the handle of the player's ship. This will make life easier later. Now we'll declare the arrays for the paths that we load from the file. We'll have an array length of 500 for both the x and y coordinates. The next path position variable we created will index these arrays. So fixed path x0 and fixed path y0 will be the coordinate pair for the first step in the path after we load it in the array. When we start the room, we'll grab a reference to the game map. Then we'll make sure the player's ship won't have an active AI. I think I'll double check that the player's ship variable has a valid reference. Sometimes I'm not sure about the object creation order. Now let's handle the AI mode actions. Since the AI paths always turn at 90 degrees and will have a line of sight with the next point on the map, we can make an easy routine to traverse the path. First, we'll find the difference between the next waypoint and the ship's current point for both x and y. Then we'll compare the differences to find out which direction we push. Remember, since each path has a line of sight with the next, only one of these comparisons should trigger at any time. We'll push the command on the top of the ship stack. So I'm pushing new commands to the ship that we have to define in the ship handler. Ideally, I'd have the player and the AI pushing the exact same commands, but I'll add that idea to the refactor list right now. We'll add these commands to the ship processing in a moment. If there's no difference at all, we should move to the next waypoint. Finally, we're at the end of the path and the AI is finished. The finished mode is simple. Set the mission complete variable to true and destroy the agent's ship. We'll keep the AI around for accountability reasons. Now let's add those AI commands to the ship. Remember, we had a separate section for AI commands that we left blank. I'll put them in there, but like I said, it's probably a good idea to merge the player and the AI commands at some point. Right now we can't do that because all the ships are listening to the keyboard. Also, we should turn off the ship variable that sets the player flag to true automatically. Now we'll have to set that remotely with the headquarters object that we're about to create. So we're only thinking about this process right now. We'll start with some variables. We'll keep high-level mission variables here so that we'll eventually load with scripts. A flag for the nighttime mission, the player kill count in this mission, and the type of ship the player flies during the mission. Now we'll make some handles for the ships. Now, obviously the player, which doesn't exist at this point. Then a handle for each of the possible 20 NPC ships in a mission. Now that we've created this object, let's uncomment that handle we had in the ship object. Also the AI handle, which we'll use soon. Back in HQ, we'll set the references, the game data object, and eventually the HUD, which doesn't exist yet. Now it's time for the heavy lifting. The first ship we'll create is the player's ship. Now to simplify all ship creation, I'm going to make a custom script that creates both the ship and its AI and resolves the references between them both. We'll call it ship create and treat it mostly like a normal object creation. Let's set the player flag, and I'll resolve this object handle to the player. Now we need to open the right file for the mission. We'll base it on the mission number. Actually, since there's so much duplication of the file names, I'll make a custom script for this. Now, ideally, we'd rename the mission files so they're all unique and count up from 1 to 59, but the episodic nature of the original game complicates this process. We'll basically have to figure out which episode we're in and play games with the text in order to match the names. If the script fails to open, we'll just force the first mission. This should never trigger. Now let's make the NPC ships by reading in the first 20 bytes of our file, which represent the types of the ships. We'll have to undo all those shifting games we played. Some of the unused ships in the file have a hex value of FF, so this is relevant. All ship values are less than 10. Let's make sure only valid ship values actually lead to a ship. Now for the waypoints. For the x-coordinate, each of the 20 ships will read in 500 possible path points. Grab the line. The first byte is our shift marker, and the second byte is the value we have to undo. We'll push that value into the ship's AI path array. Then there's the annoying case that the last ship only has 480 bytes for a path. I'm not sure what the original developers were thinking on that. Then we'll do it all over again for the Y path coordinate. Nothing changes except the array name. Finally, we want to set every ship's location to the first point in the path. We may as well set their index value here too, now that we know it. This might be better off in the ship create event based on the current instance count. Now we need to go back to the room init and replace the test ship from last time with the headquarters object, which takes over all responsibility for bringing in AI and ships. Let's test. Well, looks like we have a typo. Let's see if we can figure that out. Okay, I just mislabeled these variables. Okay, there's no player ship, but I have manual control of the camera since it's not associated with any ship now. Well, look at that. The ships are here and they appear to be moving around. Now, this makes sense for the first mission. So there wasn't a player ship. There's two possible reasons. Either it never got created or it was destroyed. Since the player ship was created in the exact same way as every other ship, I'm betting it destroyed itself. And we didn't change anything with the player ship, but we did add a case where a ship will destroy here in the AI finish procedure. But you can see that we have the player ship set to inactive. The only way the AI could get to finished is through the AI move. The player AI should never be in move and should have never made it to finished. But remember that the AI objects are created with a default to move. Well, the player ship AI carried over from move immediately to finished because the player ship had no path, or rather it immediately completed the path and destroyed itself. But that shouldn't happen because we have a room start event for the AI object that sets the player ship to inactive. The issue had to do with processing order of these objects. Now, it turns out since the AI objects are created during room start by the headquarters object, we have to ensure that it has a lower execution priority compared to its parent, or it just doesn't execute. The quick fix is to just change the depth of the AI object to anything higher than the HQ object. Now all this will change later, so let's just move it to 10 and test again. Now we're flying around with the AI ships. Let's try to destroy one. We never programmed in the collision check between blasters and ships. Let's do that now. Now, I noted the space for the check here last time, so let's add it. So if the projectile is touching a ship, and the ship is not the one that fired the shot, and is actually visible in the room, then we'll make an explosion. We'll subtract the damage from the target's shields. Remember, we set the damage in the projectile already to some dud value. So here's a quick hack. We'll check to see if the shields are below 0. If they are, we'll just move that negative value to the armor at half rate. We'll make armor stronger. And make sure the shields go back to 0. Now if the armor goes below 0, then we'll set the last hit variable to the ship to identify the person that killed it. And destroy the projectile. Alright, let's go kill some ships. Well, either the ships are too strong or the shots are too weak. The ships don't appear to die. Well, it was worth a shot. Let's add balancing to the list of things to do later. Well, I'm happy with what we've done this time around. Now that we have enemies on the screen, we'll change gears next time and get the heads-up display at the bottom of the screen. This will include building the minimap and the direction finder around the player ship.